List comprehensions in Python offer a powerful way to create new lists by looping and applying logic, all in a single line of code. Let's start with our matrix M, which is a list of lists. Each inner list represents a row, for example 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's collect the second column from this matrix. When we write row of 1 for row in M, this means for each row inside M, take the element at index 1. That gives us 2, 5, 8. That is list with entries 2, 5, 8, which is the second column. So notice the original matrix stays unchanged. Next, we can also extract the diagonal items, those that share the same row and column index. So we write it as this comprehension. So this results in 1, 5, 9. List comprehensions are not limited to numbers, they work on any sequence. For example, if you write CR into static 2 for CR in spam, so this statement basically doubles each character in the string, producing this pattern like SS, double P, double A, double M. We can also apply transformations. For example, row 1 plus 1. So this statement adds 1 to each second column value, resulting in a list 3, 6, 9. And finally, we can include conditions. This means for each row in M, take the second element only if it is even. That filters out the odd values and leaves us with a list containing 2 elements like 2 and 8. So in summary, list comprehensions give you looping, filtering and transformation all in one clear expression. So they are not just concise, they often result in faster than traditional for loops. Dictionaries map unique hashable keys to values. Keys are typically strings or tuples of immutables. Use d.get iterate with for kv in item to get both keys and values. Python dictionaries can store not only simple values but also other data structures like list and even other dictionaries. So this lets us build rich and nested models that resemble real world records. For example, JSON structures commonly used in APIs. So here we have a dictionary called rec that represent a person record. The name key stores another dictionary with first and last names. The job key holds a list of strings, different job roles. The age stores a simple floating point number. When we access rec of name, we get the entire nested dictionary. We can chain indexes. So rec of name and last navigates to the name dictionary and extracts the last value. Likewise, rec of job gives us an entire job list, and rec of job and then -1 selects the last element, that is MGR. Because lists are mutable, we can expand Bob's job list directly using append function. After running rec of job dot append janitor, the updated record now includes a third job role, showing that nested mutable structures can be modified in place without recreating the whole. So this is a key difference between list and dictionaries, which are mutable, and strings and tuples, which are immutable. The nested models gives us both flexibility and structure that is perfect for representing hierarchical data like employee records, product catalogs, or JSON from an API. Tuples are like lists but immutable. They are useful for fixed collection of items and can be used as dictionary keys when their elements are hashable. A common Python pattern is unpacking, like if you write x comma y is equals to pair, which is concise and very you could say expressive. Although the tuples are immutable, they can contain mutable objects. For example, a list of 1 comma, so the inner objects can still be mutated.